Okay, so we're going to, first of all, discuss 8.4 and then go back to 8.3. Okay, so today the menu is 8.4. Tomorrow the menu is 8.3. Yeah. All right, so let me share the desktop. And please start attending SI sessions, especially for 8.2. 8.2 was elimination and substitution. You have to make sure, you can do it really well. Okay. So if I could make an example, suppose I wake somebody up at night and you say, hey, do this problem using elimination and substitution. You have to be able to do it. That's how it is. Yeah. So even in your dream, you should be able to do elimination and substitution. That's how important it is. Yeah. Because did anybody ever dream about substitution? No, that's what I mean. It's really important. Yeah. So if for some reason you think it is difficult, then come and talk to me. Come and talk to Marlene. You have to do something about it. This is very important. Elimination substitution. Okay. So that's what I want to say about it. Okay. So other than the long weekend, I was doing well. I will tell you later. But I went to Vegas. Oh, I didn't gamble. I usually don't. So I usually just eat and then watch the show and do window shopping and look at the buildings, look at the lights. But that's what I usually do. Oh, I could really shop, right? but too bad I usually don't gamble. I should I not? Okay, so anyway, we should start 8.4. All right, are we ready? So 8.4 is system of three variables, three equations, three variables. Maybe I should write three equations, three variables. Three equations, three variables. Three variables. All right. So we usually call it 3 by 3 system. So let's read it as 3 by 3. Not 3 times 3. And when we say 3 by 3, what does it mean? 3 equations. So this is 3 equations. And this is 3 variables. Okay, so 3 by 3, 3 equations, 3 variables. All right. So what do we actually do? We actually use elimination method. So use elimination method in this section. I skipped 8.5 and 8.6, but there are other methods. So we will use elimination method. All right. So how does a 3 by 3 look? So it looks like this. So for example, I have x plus y plus z is 5. And then 2x plus y minus 2z is equal to negative 5. And x minus 2y plus z is equal to 8. All right. Okay, this is 3 equations, 3 variables. And we will use elimination method. And it's really important to label these equations because later on we will have more equations. All right. Yes? Okay, so label is important. What are you trying to do? Well, what we're trying to do, so this is the goal, the partial goal.
I know we're going to solve it, but the goal behind it is to get a 2 by 2 system. All right. So the goal, let's write down first. Goal is to have a 2 by 2 system. What do I mean by 2 by 2 system? 2 equations and 2 variables. Okay. So that's our goal. All right. So now, with that goal in mind, let's try to get the first equation with 2 variables. Okay. So which variable do we want to eliminate? Eliminate which one? X? Okay, that's fine. So you want to eliminate X from which equation? From which pair? Equation 2 and 1 and 2, you mean? 1 and 2, okay. Can you eliminate Y from 1 and 2? Yes. Can you eliminate Z from 1 and 2? Yes. So that's your choice, okay? Now, if I eliminate X from 1 and 2, what do I do to my equation 1? Multiply by -2, right? Okay. So I'm going to multiply each one of them by -2. So -2x minus 2y minus 2z is -10. So simple, I'm multiplying each one of them by -2. How about equation 2? Stays the same, we just copy. So 2x plus y minus 2z is equal to -5. All right, so we talked about why I have to multiply by -2 before, right? So now what? So cancel. So -y minus 4z is equal to -15. Yes. Okay. Can we make it simpler? I have too many negatives here. Multiply by -1, so what do I have? Y plus 4z is equal to 15. Do I have to do that? No, I don't. Can you do it? Yes, you can. Okay. So I'm going to call, this is a new equation, I'm going to call this equation 4. Yes? Okay. All right. Now, do I have a 2 by 2 yet? Where? Which equation and which equation? Not yet. I only have one equation with 2 variables. Right? But I need 2 of them. So what am I supposed to do? Yes, so we eliminate X again, but from different pairs. Remember, your goal is to have a 2 by 2. So you have this equation. How many equations is this? How many variables? 2. So I need another one, don't I? With Y and Z. If I need Y and Z, I have to eliminate X. Okay, so we need to do it another one. So as long as you have keep the goal, you keep in mind the goal, then you know what to do. Oh, I have Y and Z. I need to have another equation consisting only of Y and Z. Make sense? So that's what you have to do in life also, right? You know the goal and then you work it out. Right? So we don't just do something without knowing the goal. So we need to know the goal and then we think about how to get there. Same thing here. So we need to eliminate X again. Why X? Because I need Y and Z. Right? I need another one containing only Y and Z. Okay, so eliminate X from which one? 2 and 3 or 1 and 3. So which one? 1 and 3? Or 2 and 3? It doesn't matter. 2 and 3? You want 2 and 3? Okay. Can you do 1 and 3 though? Yes, you can. Yeah, so you want 2 and 3? Okay. So equation 2, what do? We just keep it? Okay. So 2x plus y minus 2z is -5. Equation 3, what do? Multiply by negative 2? Okay. So if I multiply everything by negative 2 here, I have negative 2x plus 4y minus 2z is negative 16. All right. Okay, so now we cancel the x. What are we left with? 5y minus 4z, you're right, is equal to negative 21. And we will label this equation 5. So how many equations do we have total? 5? Okay. Do I have a 2 by 2 now? Do I know what to do with it? Yeah, okay. So now you have a 2 by 2, we know what to do with it. Okay, so what do? We use equation 4 and 5. What do we eliminate? Yes, eliminate y from 4 and 5. Oh no, the z, right? The z. Yeah. Or if you want to do y, that's fine too. It's just a little bit longer. But who says you cannot? You can. Yeah. Okay, so basically we just copy both, right? Equation 4, we just copy. Equation 5, we just copy. Y plus 4z is equal to 15. 5y minus 4z is negative 21. Okay, then the z cancel. You have 6y is negative 6. So what is y? Okay, good. Then what? To get x, can we get x right away? No, you can get z first. Right? Yeah, because you have your equation, your 2 by 2 is y and z, so you can get c first. So substitute y equals negative 1 to equation 4. Okay. So you have, when you substitute, you have negative 1 plus 4z is 15. So 4z is, what is 4z here? 16. Z is 4. All right. What's left? Okay, which equation do I use? 1. Okay, so substitute. Okay, I'm writing really small here. Y minus 1, z equals 4 to 1. Okay, to equation 1. So x minus 1 plus 4 is equal to 5. So x plus 3 is equal to 5. Okay. Too small. What is x? 2. Okay. So what's your solution? 2, comma, negative 1, comma. So this is my solution. This is called ordered, not ordered pair, but ordered triple, or ordered triplet, or ordered triple. So x, comma, y, comma, z. Is it easy? That's not bad, right? But you have to do what? You have to keep in mind what? The goal is what? 2 by 2 system. And then you work from there, right? As long as you remember the goal, then you know what to do. Okay, should we do another one? Okay. So the goal, yeah. Yes. So you have 3 planes that, and then which intersect at one point. Yeah. So you actually have 3 planes that intersect at one point. Okay. If I could log into MathExcel, I could show you how it is, but my login expired, so I have to call the tech support. All right, are we okay? Number 2? Do you want to try first? Okay, so you want almost the same or with variables missing? Okay, try almost the same. Okay. So 2x plus y plus 2z is equal to 5. And then negative 3x, I'm sorry, not negative 3x, positive 3x. 3x minus 2y plus 3z is 4. And then negative 2x plus 3y plus z is. So 2x plus y plus 2z is 5. 3x minus 2y plus 3z is 4. Negative 2x plus 3y plus z is 8. So we label this, right? 1, 2, 3. So it should be labeling should be second nature. Because otherwise we have 5 different equations. We don't want to call them this guy or that guy. Like we plug in this guy to this guy. Well, we don't want to do that. We want to say exactly which equations, right? What is the goal again? So let's just, maybe we do them together. Well, which variable do you want to eliminate? Okay, so eliminate x from where? So eliminate x from 1 and 3. So everybody should do the same one. And then what about the other one? Do you need to eliminate x again? Yes, so eliminate x from which one this time? From 1 and 2? 1 and 2 or 2 and 3? 2 and 3? Okay. So why don't we everybody do this one? So eliminate x from 1 and 3, and then eliminate x again from 2 and 3. Okay, so we could discuss it later. Let me call the attendance. I forgot to do it. Okay, so next one? Yes. So did you ask somebody else what we did? Next one? Kevin? Joe? How did you do? Alex? Evan? Frank? Brilliant? Ray? Victor? Hussein? Alfaro? George? Angelo? Brandon?
Here.
Jandria? Jandria Rodriguez? Okay. Fernando Vega? Uriel? Johnny? Melissa? Daniel Rodriguez? Anthony Montero? Gustavo? Did I call it today? Alright, so don't take too long, okay, because we need to discuss a few more. This one takes long, but don't take too long. So you have to eliminate x from 1 to 3, right? That's what you know. And then we probably want to label this. Yeah, equation 1. Maybe it's easier to use so you get water right away? Okay. And you still have to eliminate X from something else, right? From 1 and 3, the other people didn't get it.
Oh, I didn't want to do that.
Yeah. If you're in group, I know. Okay, you yeah, so if you have to do it, excellent. You know when you label, it's just a number for not competitive. Yeah, just to make sure you're not multiplying things. If you look like you're multiplying, okay, probably that. You can, but you know how you want to do it. So if you want to link the next one, we copy it. So equation 1, can you see how I did it before?
So you see how here I have to multiply equation 1 by 2, but for your problem, do we have to multiply by 2? No, right? You simply just copy.
Where did you write that down? Equation 1, I'm going to copy equation 1. You did? Oh. This is not the biggest problem. No, I'm talking about the second one. We're supposed to do this, right?
Oh, by the way, just say if I'm too fast, then you can let me know before I change to the next section. Or you can just take a picture or something, okay, on the screen, something like that. Either way, you have to guess the number. Okay? Yeah. So we're doing number 2. By the way, if this is the problem on Math Excel, this is your portfolio. Right? This is the steps. Yeah? Okay. Yeah. Or you can take a picture.
So you can take my picture and just overview. This picture. Okay, what else another? Yes. So you elevate X. Okay, you give it. Oh. Okay, yeah. So equation 2. And then you label it. Okay, let's start.
All right, so let's start. Okay, so let's see. So what are we supposed to do first? Do I have to eliminate x? Not really, but it's just for our purpose here, right? From 1 and 3. I could eliminate y, right? Or eliminate z, it doesn't matter. But you have to decide on one. So eliminate what? X? Okay, let's eliminate X. Oh, we just copied? Equation 1 and equation 3, we just copied, right? Because we have 2x and negative 2x. So we have, what is it do we have? 2x plus y plus 2z is equals to 5. Okay, what's the second one? Negative 2x plus 3y plus z is equal to 8. Okay, so we cancel the 2x, and what about this? 4y plus 3z is equal to 13? Okay, this is equation 4. Okay, good. Now, I need, what's my goal? 2 by 2. Now, I have to eliminate x again. I cannot eliminate y this time, right? Because I need 2 by 2. My 2 by 2 is in y and z. I need another equation containing y and z. So I have to eliminate x again, but from a different pair. Which pair? 2 and 3? Okay. I could also do 1 and 2, but we choose whatever we want. Equation 2 and equation 3. Now, let's look at equation 2 and 3, and I want to eliminate x. What's my LCD? 6? All right, so I need to have 6 here, so multiply by 2. So when I multiply by 2, each one of them, what do I have here? 6x minus 4y plus 6z is 8. Okay, good. So I have my 6x. What about equation 3? Multiply by 3. So we have, what do we have? Negative 6x plus 9y plus 3z is 24. So we multiply each one of them by 6. But I'm sorry, by 3. Okay, now what? You add this, the x cancel. We have 5y plus, is it 9z? Equals 32. Yes. So we will call this equation 5. Okay. Let me pause here a little bit. Is everybody okay with this? Yes? Continue? Do I have a 2 by 2 now? Yeah. So notice that my 2 by 2 consists only y and z. So that's why I have to eliminate x both. I cannot eliminate x the first time and then later on I eliminate y. No. You have to be consistent. If you want to eliminate y and then y again, z and then z again. Yeah? All right. Now I have a 2 by 2 and let's see, which one do you want to eliminate here? The z? Okay. The least common multiple is 9. Yes. So eliminate z from 4 and 5. Yes. All right. So eliminate z from 4 and 5. Oh, this is 3 and this is 9. What is my least common multiple? 9. So equation 4 we will multiply by negative 3. Yes. One has to be positive. The other one has to be negative. So negative 12y minus 9z is negative 39. Yes. Equation 5. Just keep it, copy. 5y plus 9z is 32. Yes. Now what? Negative 7y is negative 7. So y is 1. Okay. All right. The negative, is it? Okay. So, what am I supposed to do next? Do you think I could substitute y to equation 1, 2, or 3? No, not really. If I substitute to equation 1, I will have x and z. Right? So I don't. Which equation do I substitute it into? Either 4 or 5. You choose one. Which one's easier? 4 is easier, smaller number? Yeah, okay. Substitute y equals 1 to equation 4. Okay, so 4 times 1, so that's 4. Plus 3z is equal to 13. So 3z is 9, z is 3. Okay. What next? Substitute y equals 1 and z equals 3 to equation 1. Okay, the easiest one. Can I do 2 or 3? Yes. But choose the easiest one. We don't want to make our lives harder, right? 2x plus 1 plus 2 times 3 equals 5. 2x plus 7 equals 5. Good. What is 2x equals to? Yes, x is negative 1. All right. So, what's my solution? Negative 1, 1, 3. Yes. Finish. So what do you think? This is doable or not? Yes? Okay. So we're going to do 2 more. And then we will finish with this section. Yeah. Questions? Problems? Oh, sure. Does anyone have a question?
Can you do something by substitution?
We usually don't do substitution for 3 by 3.
Why is that?
It makes it very complicated. So if you how are you going to do substitution here?
Because if there is a variable, where I have Windows, I display the information.
You can, but it's usually not common. So if you solve, for example, solve for x, right, and then you have something in y and z, and then you substitute to the other one, you still have let me see. Okay, think about it. If you solve for x, you have a y and z, right? And then you substitute it to the other one, you still have y and z. So you have to substitute twice. So let's just say you solve for x in equation 1. Then you have y and z, you substitute to equation 2 and equation 3, then you have a 2 by 2. But it's usually not common. You could try it, it should be the same answer. Yeah? Okay, good. Are we done? All right, why don't you try this, number 3. Let's see here. 3x plus 2y is negative 2. And then 2x minus 3z is 1. And then 0.4y minus 0.5z is equal to negative 2.4. So what are you supposed to do first here? Oh, that is my, yeah, here it is. What do you think we're supposed to do first? We have decimals here. Do we like decimals? Okay, so now we will clear the decimal. How? Yeah, multiply by 10, which is 4y minus 5z is equal to negative what? 21. Yes? So I'm going to call this equation 1. This is equation 2. And my third one is the one with the decimals clear. All right. Okay. Now I actually can erase this, right? Or I could actually like scratch this out. Okay. You could erase it if you want. Yeah. But if we have fractions, we will clear the fractions. If we have decimals, we will clear the decimals. Okay, now I'm going to stare at it a little bit. And I'm going to look on my first equation, what variable is missing? Okay, what about the second one? What about the third one? Okay. So on each one of them, one variable is missing. Does it make our lives harder? No, it makes our life a lot easier. Okay? Don't you think? Now, what do you think you'll do? You want to eliminate x or y or z? Eliminate y? Okay, from which equation then? 1 and 3? Okay, so let's do that. Can we eliminate x instead? Yes, from 1 and 2. Or can we eliminate z? Yes, from 2 and 3. So, but if we choose to eliminate y, we will do eliminate y from 2 and 3. Alright, so let's see the y's. Oh, the y's are from 1 and 3, I'm sorry. Yes, 2 doesn't have y. Where does it come from? 1 and 3. So let's see here, the y, this is 2 and this is 4. So what is the LCD? 4. Okay. So what do I do to my equation 1? Multiply by 2. Yes. So multiply by negative 2. Yes. So when I multiply by negative 2, let's see. What do we have? Negative 6x minus 4y equals 4. Right? What do we do with equation 2? Yeah, just copy. 4y minus 5z is negative 21. All right. So the 4y cancels with negative 4y, and we're left with negative 6x minus 5z is negative 17. All right. Or we could make it simpler, right? We don't want to have a lot of negatives. Or we could leave it the way it is. It's up to you. But I usually change this into positives. How do I change it to positives? Yes, so 6x plus 5z is 17. So this is equation 4. All right. So are we okay so far? Yeah. Now, what is my goal again? 2 by 2. Now, I'm going to look here. Do I have a 2 by 2? What's my variable? X and z. Do I have a 2 by 2? Where? Equation 2 and 4. So, look at these. I don't need to eliminate y again. Remember before we eliminated x how many times? Twice. Right? Here, do I need to do it? No, only once. So this is my 2 by 2, equation 4 and equation 2. So I have x and z here. And then do we know what to do? Well, yeah, if we have 2 by 2, we know what to do. Here you can do substitution. What's your name again? Sorry. George, yes. George, here, if you have 2 by 2, you could do substitution, right? If you want, but not until we have 2 by 2, right? But it's always easier. Look at these, the coefficients are not 1, so it's easier to do elimination, right? Yeah. Now, which one do you want to eliminate? You have a 2 by 2 now. Eliminate x or z? X from 2 and 4. So here I have less work compared to before, right? Because here I have a 2 by 2 already in x and z. I only need to eliminate y 1 time, not 2 times. Let's see, the x, let me erase this first. What's my LCM for my x? 6, so equation 2 multiplied by positive 3 or negative 3? Negative 3? Okay. So you have negative 6x plus 9z is equal to negative 3. And then equation 4, we just copy 6x plus 5z is 17. All right. So what do you think here? 14z is 14. Z equals 1. Good. Okay. Now we do the rest. What do you think we will do the rest? Can I substitute to equation 2 or 3? Yeah, here we can, right? Because equation 2 or equation 4. So substitute z equals 1 to which one? Equation 2? Okay. So when we substitute, we have 2x minus 3 times 1 is equal to 1. 2x minus 3 is 1. 2x is equal to negative 2. X is negative 1. Is it? Oh, actually it's 4, isn't it? Yeah. Well, how did I get negative 1? I don't know. This is the coffee thing again, right? Okay. So x is equal to 4. 2x is equal to 4 and x is equal to 2. Thank you. Now what? Substitute. You need y, right? Okay. Substitute x. X is equal to 2 to equation 1. Or you could say I substitute z equals 1 to equation 3. It doesn't matter. But you need y. So you have 3 times 2 plus 2y is negative 2. So 6 plus 2y is negative 2. What is it? 2y is negative 8. Is it? Y is negative 4. Okay. So what's my solution? 2. Yes. Do you feel pretty good about it? Can you tell the difference between this number and the previous one? What's the difference? Here, what do you do? Yes, you only need to eliminate y once because you have a 2 by 2 already, and this is your 2 by 2 here, equation 2 and equation 4. So you only have 4 equations. Could we do one more? Okay. So let's do one more. All right. No problem? Okay. Usually, for some people, this is hard, but not for you, right? Oh, by the way, I would like to thank you. Today, I went around, okay, and everybody in the class was trying the problem. So I'd really like to thank you for that. I appreciate it. Yeah, that's how it's supposed to be, right? Yeah. Okay. Good. But it's very good. So everybody is trying, even though you cannot. You try. It doesn't matter. The willingness to try is the most important. Okay. If you're not willing to try, then that's it. There's nothing we could do. But if you're willing to try, to give it a shot, then there will be something we can do, even though you didn't do it right. It doesn't matter. Yeah. All right. So here we have to do a lot of cleaning, right? Fractions and decimals. So let's write down the cleanup here. So Okay, so how do I clear the fraction? By 2? Yes. So multiply everything by 2. So what do we have here? 3x plus 2y. I'm sorry, are you done? Maybe I should read. So 3x plus 2y minus 2z is equal to 0. So 4y minus 3z is equal to negative 22. So this one I just copy. How about the last one? Yes, which is, what do we get? Negative 2x, yes, plus 3y is equal to negative 20, right? Not 2. So we have to multiply by 10 each one of them. So 1. Oh, 0 times 2 is 0. Yeah, that's right. You're correct. So 0 times 2 is 0. Yeah, good. Now, let's see here. What do you think you will do? I'm going to stare at it for a while and then let me think. Stare more. Or there's a song, what is it? Stop and stare. You know the song? I don't remember who sings it. Coldplay? Anyway, a long time ago. Now I'm going to stare at it for a while and then let's see. Oh, equation 2 is missing x and equation 3 is missing z. So what would you do? We eliminate y? Then we have to do it twice, right? If we eliminate y. If I eliminate x or z, then I have to only do it once. Right? If I eliminate x, look at this. Yes, you can. So you eliminate x, not eliminate y. Why do I choose to eliminate x from 1 and 3? Or why do I choose eliminate z from 2 and 3? Right, so you only have 4 equations. If I eliminate x from 1 and 3, how many equations will I have to have? 4 only, not 5. If I eliminate y, I have to do it twice. Then I will have 5 equations. So which one, more work or less work? Less work. So then, oh, you want more? That's fine too. I don't want more. So we should eliminate x from 1 and 3 or z from 1 and 2. Do you see the idea why? Yes, you know the reason why. But if you choose to eliminate y, no problem. It's just more work. Yes? Okay, so let's see. Which one do you want to eliminate, x or z? So eliminate x from 1 and 3. Okay. All right, equation 1, we will multiply by 2. Okay. So I'm just going to do it really slowly. I'm going to multiply each one of these by 2. So 6x plus 4y minus 4z is 0. So I'm multiplying each one of them by 2. How about equation 3? Times 3. So I'm going to do it really slowly. Negative 2 times 3 is negative 6x plus 9y equals to negative 60. All right. So what do we have now? 13y minus 4z is negative 60. So I'll label this equation 4. Yes. Do I need an equation 5? We do? We don't have a 2 by 2 yet? Yeah, we do. We have a 2 by 2. Which equation? Yes, 2 and 4. Yes. So this is your 2 by 2, right? You have y and z for both. Okay, now what should we do? Eliminate z from 2 and 4. Yes. Okay, let's see. Equate. What's the LCD? 12? So you have to multiply these by -4? Or, yes? Oh. Okay. So equation 2, you multiply by -4? Okay. So either one, 4 or -4. So you have -16y plus 12z is equal to 88. So we multiply each one of them by -4. Okay. How about equation 3? Oh no, equation 4. By 3. Okay. So 39y minus 12z is equal to -180. So what am I left with? 23y is equal to negative, no, is it? Is it -92? Yes. Okay, so what is y? Divide by 23 both sides, y is equal to negative. Okay. All right. So what next? Yeah. So substitute y equals -4 to equation 3. Okay, so you'll get x first, right? Or equation 2, you get c first. It doesn't matter because this is missing. When the equation's missing variable, it's fine. So equation 2, so you have 4 times -4 minus 3z is -22. What next? -16 minus 3z is -22. That's right. And then you bring the -16 to the other side. So plus 16 both sides. -3z is equal to -6. So z is 2. All right. So by the way, I'm not writing plus 16 plus 16, but can you write it? Yes. But you see how I didn't write the plus 16 plus 16? Yeah, but you can write it as long as you write it to both sides. Yeah, so I could write like this, plus 16 plus 16 if you want. I just did it. And then here I could divide by 23 both sides if I want to write it. Yeah, those are good if you want. Next, we're almost done. Y equals -4 to equation 3. All right. So when we substitute, what do we have? -2x plus 3 times -4 is -20. -2x minus 12 is -20. Then what am I supposed to do? What do you do next? You add 12 both sides, so -20 plus 12 is -8. So what is x? 4. So 4, -4, Okay? Okay. So how many people think this is doable? Doable? Okay. Good. So there are some which has no solution, but you'll find it. You'll have 5 equals to 7 or something like that. Or you have some that have infinitely many solutions. Yeah. Now, you will have that on your homework, in your Math Excel homework. So I'd like you to try them. If you have questions, you can let me know tomorrow. I'm not going to put the due date until when? Sunday, but in general, if I finish on Tuesday, when will it be due actually? Wednesday, 11:59 p.m. Right? Does it mean that you cannot open after? No, you can open. It's just 10% off. So everybody clear about Math Excel? Did everybody get the Math Excel? No? Yeah, now it is the last day of September, the last day of school in September. Yeah, I have to change it. Yeah, as the day go along, I change them. Like on Friday, I was about to change it, but now I couldn't log in. So in a few days, I will log in and change the due date. No, it will be changed. So as of right now, everything is. Yeah. So as of it's gonna be changed as we go, as we move. Yes. As of right now, it's the last day of class. So who didn't get Math Excel yet? Gustavo? Who else? Nestor, right? And Hector also. Can you guys get it today, or is it difficult? Yeah, you need to log in. Yeah. So done 8.1, 8.2, and 8.4, right? So tomorrow we're doing 8.3. Yeah. Okay. So tomorrow 8.3. I'm skipping 8.3 today, but tomorrow we will do 8.3. Okay, guys. Are we off today? Are we done today? Yeah. Okay. All right. We'll see you tomorrow. Thank you today. It was good. Okay, so today we're done with 8.4, system of equations. Tomorrow we will do 8.3. Thank you.